Let's look at what's going to happen when we've got CO2, carbon dioxide. And we'll get a review on molecular shapes, but for now we're going to remember that carbon dioxide is double bonded to some oxygens, with those oxygens having lone pairs of electrons. Now, when you add this to water, you're actually adding it to the hydroxide ion, which, as we just said, acts as a great Lewis base. And what happens with the hydroxide ion is it comes in here with its, again, lone pairs and its negative charge overall, and is actually able to donate some of those lone pairs to carbon. So those lone pairs get donated to carbon, and we end up with a totally new situation where we've got a carbon in the middle still. Carbon's always in the middle, double bonded to one oxygen still, looking just like it does on the other side of carbon dioxide. But when carbon decided to bond with this oxygen, it had to let go of one of these bonds. So you end up with a bond out here to an oxygen. That oxygen's going to get those electrons back. Carbon doesn't need them anymore, so oxygen's going to get those electrons back in that bond. It's going to be surrounded with lone pairs. It's going to have a little bit of a negative charge out here, and that carbon's going to also then bond to that OH group that we already had. Now, we are probably not to the point where we look at that structure and can easily see what it is. But if you actually draw out the formula for this, we're looking at a HCO3, better known as our bicarbonate or hydrogen carbonate ion.